Hi, I'm Brianna, host of Grayhill's Tech Talks, and in this episode, we'll be speaking with our product engineers about how to properly evaluate an encoder's lifecycle performance. We'll break down what a lifecycle really means, what end-of-life ratings actually tell you, and how extreme temperatures can expose major differences in real-world performance.
Hi, my name is Scott Nissen, and I'm the business unit leader of Grayhill's Advanced Components Group.
Hello, my name is Jared Janota. I'm the business unit leader for mechanical components. Mechanical and optical encoders are both taking rotational input and turning them into electrical signals. They're just doing it in different ways. Mechanical systems are using physical contacts, and optical is using light. For mechanical encoders, they can be designed to have a higher temperature range, specifically on the low end, since they don't contain any sensitive electrical components. They can be constructed to have higher ratings for mechanical shock, vibration, and thermal shock. The downside to a mechanical encoder is it's limited by mechanical wear. So if you have an application where you need a switch that's rated for a high amount of cycles, that's where you want to look into an optical encoder.
Grayhill optical encoders are rated for 1 million rotational cycles minimum, but the important question is, what is a cycle? Grayhill defines one cycle as 360 degrees clockwise rotation, followed by a 360 degrees counterclockwise rotation. This reflects real-world use because users adjust up and they adjust down when using the encoder. That's
one cycle as defined by Grayhill. Many of our competitors will define a cycle as only a 360 degree rotation. So when you're evaluating different data sheets from different manufacturers, you want to look at how they're defining a cycle. You may think you have a 1,000,000 cycle rated switch, when actually, compared to Grayhill, that's only a 500,000 cycle switch.
In addition, Grayhill specifies that after 1 million rotational cycles, the encoder must still maintain at least 50% of the initial torque. Many competitors cannot meet this torque stability throughout life.
In addition to that, the 1,000,000 cycle rated switch could only be available without detents, completely smooth rotation. So detents are the little clicks you can hear and feel that define specific positions. If you want the competitors' detented versions, they'll offer different torque levels. And as those torque levels increase, their cycle rating will dramatically decrease. So you may think that you found a 1,000,000 cycle switch, realizing I need detents. Suddenly you're down to a 100,000 cycle switch, and then when you compare that to how Grayhill rates their switch, that's only a 50,000 cycle rated switch.
This is a clip of our manual detent torque tester. The operator places the encoder shaft into the torque transducer and then manually rotates the encoder from detent to detent. At each position, the operator clears the reading and records the torque value, which is automatically sent to an Excel spreadsheet. From this data, we calculate the average rotational torque and the detent torque range of the encoder. So now let's talk about some testing we recently did on Grayhill 62AG and 62SG versus Brand X. This graph shows detent torque degradation over rotational life. We tested the Grayhill 62AG and 62SG against two competitor encoders. Grayhill specifies that after 1 million cycles, the rotational torque will still be at least 50% of the initial torque value. As you can see, both the 62AG and 62SG maintain very consistent torque through 1 million cycles, while the competitor encoders show significantly greater degradation. This consistency helps preserve the haptic feel of the encoder throughout its life. This graph shows the variation from nominal torque at each detent position for the Grayhill 62AG and 62SG compared to two competitor encoders. The x-axis represents each detent position over one full rotation, and the y-axis shows the percentage variation from nominal torque. Ideally, you want this variation to be as small as possible so every detent feels consistent. As you can see, the Grayhill 62AG and 62SG maintain much tighter torque consistency across all positions, while the competitor encoders show significantly larger variation. That larger spread results in more uneven haptic feel as the knob rotates.
Thank you for staying tuned to this Tech Talk, and don't forget, Grayhill engineers are always here to support you in your next project.
And that's the end of this episode of Tech Talks. Thank you for joining us as we learn how to properly evaluate encoder performance with our product experts. Leave a comment down below about any future topics or conversations you'd like to hear from Grayhill, and be sure to subscribe to our YouTube channel so you can follow along for any future videos.